What is the relationship between points, lines, and planes? Points, lines, and planes are the most basic elements that make up figures. If we place a single point, it feels as if a whole world is beginning. If that point moves just a little, a line appears, and if the line moves again, a plane unfolds. The opposite is also true. Planes are made of many lines, and lines are made of many points. Points, lines, and planes are both the building blocks of figures and the way figures are formed. A point has no size, but it defines a position. Because of this, even with just 2 points, we can think about distance. In mathematics, we first decide how to measure distance. Usually, we consider the length of the line connecting 2 points as the distance. But sometimes we measure horizontal and vertical movements separately, or we add them together and call that the distance. When we look at a map, we often imagine the straight line distance between 2 points. But when we take a taxi, the distance along the roads is more realistic. In our everyday life, we call both distance measures. The definition of distance changes depending on what we imagine. Let us take a closer look at lines. There are infinitely many lines passing through a single point, but if we have 2 points, the story changes. Only one straight line passes through 2 points. When there are 3 points, there are different possibilities. If the 3 points lie on the same straight line, we're still talking about lines. But if the 3 points do not lie on a single line, they define a plane. As more points are added, we move from the world of lines into the world of planes. Lines appear where planes meet. When 2 planes meet, a straight line is formed. When a surface and a plane, or 2 surfaces meet, a curve appears. A single point is formed where 3 planes meet at the same time. Think of a box. Where 2 planes meet, we get an edge. Where 3 planes meet, we get a vertex. Here, points, lines, and planes appear through one another. Now let us summarize how they meet. When we have a point and a line, the point is either on the line or outside it. The same is true for a point and a plane. The point is either on the plane or outside it. 2 lines on a plane can overlap, meet at a single point, or never meet. In space, there is one more possibility. 2 lines may not be parallel, and yet they do not meet. This is called a skew position. We can also describe the relationship between a line and a plane. If a line passes through a plane, they meet at a point. If a line lies on the plane, it is part of that plane. If it touches neither, we call the line parallel to the plane. 2 planes in space can be parallel or meet to form a line. When 3 planes meet, they form a point again. In the end, points, lines, and planes are not separate things. They are connected through relationships that create one another and define one another. Lastly, let us picture the moment a solid meets a plane. When a plane cuts through a solid, a cross-section is left behind. Depending on the solid's shape and the cutting direction, the cross-section changes. A cube, for example, can produce triangular, quadrilateral, pentagonal, and even hexagonal cross-sections. But a sphere is different. Cut it from any direction, and the same circle always appears. The shape may change, but the relationship stays the same. Points, lines, and planes are not things to memorize as definitions. They are a language of relationships, revealed through one another. That is why math often takes us beyond shape and into practice reading relationships.